Hi Year 5, it's Mr. Philpotts here with our next maths lesson. Today we are focusing on prime numbers, something we did a few months back, so a little bit of revision and a few puzzles and problems to solve. But before we get on to that, I just want to mention TT Rockstars. I've been looking at the fastest times in all of French. And you might not believe this, Year 5, but the top 13 places are all Year 6 children with phenomenal speeds. Their ability to answer the times table questions is absolutely superb. So the reason I'm mentioning it is my challenge to you is, can you break into that top 13? That means you're going to have to answer questions quicker than a second a time. So it could be 2 questions per second if you want to get into the top 13. So it's going to take a lot of hard work and a lot of practice, but I would love it if we could break the top 13 and give Year 6 a little bit of run for their money. So that is your challenge this week, alongside what we are doing in our maths lesson. So good luck with that, and let's move on to our prime number lesson. Okay, so if we cast our minds back to prime numbers, hopefully you can remember a few of the features that makes a number a prime number. So for example, it is a number that is greater than 1 and it has no divisors other than 1 and itself. So if you look on the screen, I have highlighted all the prime numbers between 1 and 100. Remember, there are no even prime numbers except for the number 2, and there are no prime numbers ending in 5 except for 5 itself. So just think back again, it can only be divided by 1 and itself. Those are its only factors. That is what makes a prime a prime. So we're going to have a go at a few problems. So let's have a look at the first one. So on the left, I've got a few numbers, and I was wondering, can you, thinking about what you know about prime numbers, work out whether they are in fact a prime number or a composite number, which is a non-prime number. So we've got 2, 7, 12, 17, 21, 29, 32, 41, 67 and 82. At this point, you can pause the video, have a think, what are the factors of these numbers? Is it 1 in itself, or does it have more? Think about your times table knowledge. If you're stuck, you can go back to the slide we looked at a minute ago. Pause the video, have a go, see if you can work out which of the 2 categories to go into. Right, once you've done that, hopefully it should look like this. So our prime numbers there were 2, 7, 17, 29, 41 and 67, and our non-prime numbers are 12, 21, 32 and 82. So well done if you've got those right. If you've got a few muddled, that's fine. Try and spend a minute now and write down the factors of that number and see if you can work out where you went wrong. Right, moving on. So next thing I want to have a look at is, I've got my 2 columns that we've mentioned already. Now, can you identify all the prime numbers between 50 and 70? Try not to look at the grid to begin with. See if you can work it in a logical way. So what I would do, I would start at 50 and think, right, what are the factors of 50? Well, I know it ends in a 0, which means it's an even number. So straight away, I can rule that out. It's not a prime number. All my even numbers. So that's 50, 52, 54, 56, and so on. So that's half the numbers out of the way already. Then have a look at the other numbers. So if we look at 51, what are the factors of 51? Can you draw a factor grid to help you solve it and work your way through? Hopefully, once you've had a go and then pause the video, it'll look a little bit like this. So we've got 53, 59, 61 and 67. Okay, again, don't worry if you haven't got them. Go back and have a look at the grid and then have another go at the problem. That's absolutely fine. But remember, we are creating a factor grid like we've done in the classroom. So what are the factor pairs? If you take the number 10, for example, We know 1 and 10 multiplied together is 10. 2 and 5 factors. 3 is not a factor of 10. You can't multiply 3 by another number and make 10. So work in a logical way as we've done already this year. Right, let's have a look at the next problem. So we're just sort of practicing and revising a little bit at the moment. Right, a little bit of reasoning. So you're going to use the clues to find the possible numbers. Okay, you might want to use your prime number 100 square, or if you're feeling confident, try and do it without first. So it says, I am a prime number less than 100. I am 2 less than a multiple of 25. What number am I? I think the first thing I would do is write down my multiples of 25. So count up in 25. So we've got 25, 50, 75, 100. I don't need to go any higher because of the first clue. What's 2 less than those? So what's 2 less than 25? 2 less than 50, 2 less than 75, 2 less than 100. There should only be 4 options. Now, knowing what you know, can we work out which ones are prime numbers? So pause the video, have a look at the numbers you've got in front of you, think about what we know about prime numbers. Can you find the solution? Hopefully you've got the answers 23 or 73. Well done if you've got those two as before. If not, have another go, or now you've seen the answers, can you work out why they are correct and the other options weren't? Right, and then another problem I want you to have a go at. So this time, can you arrange the numbers in the circle so that each adjoining pair, so that means the ones that are next to each other, add to make a prime number? So you've got the numbers 10, 2, 5, 1, 6 and 13. Can you put each number in the square? Sorry, each number in a circle, not a square at all, I don't know where that came from, and to complete it, and then work out if the pairs together make up a prime number. Pause the video, maybe write the numbers on scrap bits of paper so you can move them around and rearrange till you get the right combination. And then once you think you've got it, play the video again and let's see if we match. So you should have, I'm going to start at the top left of mine, 13 and 10, because you've 13 plus 10 is 23. 10 and 1 makes 11. 1 and 2 is 3. 2 and 5 gives you 7. 5 and 6, that's 11 again. And then 6 and 13 gives you 19. So all those pairs added together gives you prime numbers. Right, let's, now we've had some practice and revise what prime numbers are, let's have a look at our chilies. So, chili 1 today looks a little bit like this. So, it says place the numbers 1, 2, 3 all the way up to 9 on a square of a 3 by 3. So if we'll have a look at the little diagram at the bottom there as an example, so that all the rows and columns add up to a prime number. Two solutions are considered to be the same, like in the example below, they contain the same 6 triples. How many different solutions can you find? So if you look at the first example, it's got 2, 8, 3, 6, 4, 9, 5, 7, 1. If I add 2 plus 8 plus 3, I get 13, prime number. 6 plus 4 plus 9 is 19, prime number. 5 plus 7 plus 1 is 13, prime number. And the same if I count from top to bottom in the columns as well. So can you place the numbers 1 to 9 in a similar grid and make prime numbers yourself? That's what I want you to do. So first thing I would do is write the numbers 1 to 9 on some scrap bits of paper, rip them out, cut them out, whatever you want to do, and rearrange them into a square, and then move them around until you find a solution. How many solutions can you find? Okay, chili 2 this week. Can you show, so it's kind of linked to chili 1, can you show that it is impossible to place the numbers 1, 2, 3 up to 9, 1 on each square of the same grid, so that the diagonals add up to prime numbers? So you've got to show that it's impossible to do. Okay, have a little think about what that means. That means you've got to prove that it can't be done. So you need to do a lot of rearranging to show that is the case. So you'll need to look at the solutions that you did for chili 1 first, and then use that as evidence to prove that it can't be done for Chile 2. And then finally, this week, Chile 3 looks a bit like this one. So we've got 10 cards numbered from 0 to 9. The 0 is important. Don't forget that one because it is easy to ignore. Using all 10 cards, can you rearrange them to make 5 prime numbers? Okay. And then can you find a way of doing it with 5 two-digit numbers? So you might have to be a little bit creative with that 0. And then how about using a 1-digit number, a 3-digit number, and then 3 two-digit numbers? So again, rearranging the cards to meet the requirements of those problems. Remember to send in your solutions to all of these Chiles to the Year 5 email address because we do enjoy seeing how you're getting on. It's really important. So again, as I've said before in other weeks, good luck with the problems. If you are not sure anything, again, you can use the email address to check with us. And we look forward to seeing how you get on. Thank you, Year 5.